All right, this is cool. I think you're going to really like this. You can cast shadows in OpenGL. And at first it seems like you shouldn't be able to do this because you've seen how this draws is it draws a triangle and then throws it away until the next time it draws the triangle. That is, it doesn't keep information around in order to cast the shadow because really you need information kept around. You need to know who's blocking the view of this triangle from the sun. Well, yes, you would be right if that's what you were thinking. The way it works is a two-pass algorithm. It's called a two-pass algorithm, means you're going to render the scene twice. The first time we're going to figure out where views of the light are blocked, and the second time we're going to draw the scene again with that in mind. So here we go. Okay, so step one, identify where the light source is that's casting the shadow. And if you think about it, if you put your eye at that light source, like here, then if you were to render the scene from the point of view of the light source, not the point of view of the eye like we normally do, but if you render it from the point of view of the light source, it looks like this. And anything that you can see will not be in a shadow. That is the light. Anything the light can see is not in a shadow. Anything you can't see is in a shadow. Okay, so what we're going to do in step one of this two-pass process is we're going to render from the point of view of the light, and we're going to upload the Z buffer. Okay, we don't care about the colors right now. We'll get the colors in the second pass. But what we do care about is the depth. And so we upload the depth buffer. This is a grayscale image of depths. And what we're going to do, let's say we render this cube, we draw this cube again, and there are parts of the cube that are down here. If I render the part of the cube that's down here, well, I know that the Z value of that part of the cube is farther away from me than the closest thing, because remember, the Z buffer keeps track of the closest thing. And if it's farther away from the closest thing, I know it's in a shadow. Okay, that's the strategy. And you get cool looking shadowed effects. And the shadows really are a wonderful depth cue. You know, you look at the bare scene without shadows, you look at the scene with shadows, and the scene with shadows is so much richer than the one without. Okay, but now we need to do this in OpenGL. So the first pass is going to be to generate the Z buffer, and we're going to upload it, except we're not going to upload it to the CPU. That's too slow. We're just simply going to upload it from one part of GPU memory to another part of GPU memory, and we're going to treat that second part of GPU memory as a texture. Okay, so we are rendering not to the monitor, but to a GPU memory frame buffer. And we're not rendering any colors, we're rendering just depth. And we're going to end up with an image that looks like this. So this is a sphere with a couple of rotating cubes. Anything that's white, well, that means very far. that means basically the Z buffer is at infinity. Anything really dark is close to me, and anything intermediate is somewhere in the middle. Okay, here's what we're going to do. You've seen gen textures. It generates an ID for the textures. There's also a gen frame buffers. Normally the frame buffer is where the monitor is. We can make the frame buffer somewhere else. Okay, we're going to gen the texture, bind the texture. It's a depth texture. We're going to just draw the depth. And notice this text image 2D. Instead of RGB like we've done before, we now say depth component. Um, and we also, where we normally have been putting an array of texture image data, we're putting null, meaning make it this big. Here's the width, here's the height, but don't put anything in it. Well, that's because we're going to render into it. And the reason it knows to render into it is we bind the auxiliary memory frame buffer, But this is the magic call right here, is essentially says, take this texture and link it as the frame buffer. Okay, so we are going to render, but instead of rendering to the monitor, it's going to render into this texture that's just sitting there. Okay, ready, set, draw the scene. That's the first pass. Now, the second pass is to draw the scene with some memory of that first frame buffer, the depths that we got. Now I did this in GLM, so at the same time you can see how GLM is working. Here is our shader that we're going to run to get the depths. We've got a transformation, and this is essentially a look at, okay, oh look, GLM look at, from the point of view of the light source. So our first pass is we're rendering from the point of view of the light source. So instead of passing in a GLU look at matrix from the point of view of the eye, this is from the point of view of the light source. Okay, we're drawing the scene. Now we're using a second shader called render with shadows. And that shader is being told where the light is. And so every time we go to draw something, every time we go to draw a fragment, we're going to look up where that fragment is with respect to where the light is. And that's how we'll know that is the depth at that point blocked by something else. Okay, so we are setting up the view, and this time it's a view really from the point of view of the light. We draw the scene and we turn it off. Now, the getting the depth, the first set of shaders when we were getting the depth, really this was pretty easy. This is the look at from the light. This is sort of like what we've done before. And we send the position down because we do need to render it. This we don't really need to do, except some GLSL compilers will complain if you don't set frag color. So we're doing it just to keep the compilers happy. But because we're not rendering any colors, doesn't matter. Okay, we're really just acquiring a full screen worth of depths. Here's what we do when we're rendering with shadows. This looks like the same as you've already seen. It's doing per fragment lighting. These are the vectors. The vectors are out variables from the vertex shader. This is the fragment shader, the first part of the fragment shader. And what it's doing is it's figuring out where the entry in that depth texture is with respect to the thing it's trying to render right now. And really that's what's going on right here. If the current depth is deeper in depth than the closest depth, that means something is blocking this fragment from seeing the light, and it's going to be in a shadow. Here's the rest of that shader. We're doing per fragment lighting, and so that's really all that's going on right here. This is exactly our per fragment lighting code that we looked at in the shader notes. The real trick is right here. It calls that function from the previous page called isInShadow. And when people think about shadows, what they tend to think is if you figure out it's in a shadow, paint it black. But it's actually easier than that. Is if it's in a shadow, don't do the lighting, the diffuse and specular lighting. The ambient gets done no matter what. That's what's going on here. But if you find out it's in a shadow, simply don't do the diffuse or the specular. The diffuse and the specular depend on the light being able to see this fragment. And so here's what you get. Be sure to watch the demo video that goes with this because what you'll see is this, and these cubes are rotating so the shadows change shape as they should. But in that program, we can toggle and take a look at this depth map. And actually, you'll see the cubes rotating as these dark spots on the depth map. Now, how did the demo program render this? Easy. Um, Basically, it took that depth map texture and treated it as colors, as grayscale, and then drew a quadrilateral and mapped that texture to the quadrilateral. So poof, okay, that was not too hard. And there it is. Here's where it's reading that texture. There's only one element in it, it's the depth, but it's the first thing in it, and which makes it look like the .r component. We'll call that gray, and then if we repeat it 3 times, we'll get a grayscale. So anyway, be sure to watch the demo video that goes with shadow casting, because I think you'll like it. You're not required to do shadows for any of the projects in this class, although it turns out that a lot of people use it in their final project, just because it makes it look so much deeper, so much richer. So have fun with this.